everybody, it's Ms. Phoebus and I'm back with another Algebra 1 EOC review. This is day 13. Here's problem number 48. Alright, so we have an equation. It is an exponential equation because there's a t in the exponent. They want to know about percentage. So this is that r component, what's going on inside. So the question is, am I adding something to 1 or am I subtracting something from 1? I am adding something to 1. I have something larger than 1. So that means I have an increase. So that means that B and D are looking good. C and A I can throw out because those indicate a decrease. A decrease would be an exponential decay. I would have something smaller than 1. Question is, what percentage am I dealing with? So if I think about 1.04 and I subtract off 1, right? What am I adding to that 1? I get 0.04, which is not a percent. Remember, in order to look at R being a percent and then changing it to a decimal, we had to move that decimal place, right? So we want to move that decimal place back, and we're looking at 4% increase. We are going to choose D as our answer. All right, we've got problem number 49. All right, you have 3 scatter plots, A, B, and C. You have 3 numbers, negative 0.9, 0, and 0.9, and they want you to do the correlation coefficient, which one best matches. So the idea here is that correlation coefficient, that little letter R, is on a scale. That scale goes from -1 being the strongest that you can be, the strong negative linear correlation, to a +1, which would indicate a strong positive correlation. Now, that's not the only things that we have here. In the middle of this, we have 0, and 0 implies no correlation at all. And then you have different variations. You have at 0.5, you have a weak positive. But there's even other numbers. And so, like, if we were dealing with, I don't know, like 0.6. 0.6 is really close to being a weak positive. It's closer to 0.5 than it is to 1. So it's closer to being a weak positive than a strong positive. And so you kind of have to play around with that. And then sometimes they even get these weird, like, so like here's negative 0.5. At negative 0.75, they may say it's a moderately strong negative correlation, okay? But it's all about the strength. Negative, I don't know why I did that. It's all about the strength and how close are you to 1 or -1 or 0, that kind of thing. So as you get closer and closer to 0, your dots get further and further apart, and they also don't look like they're headed anywhere. So if we were looking at negative 0.9, if we were looking here, which scatter plot best fits? Well, we would want one with a negative slope where the dots are kind of getting close together, almost in a straight line. With a -1, they would be in one straight line. So I'm thinking scatter plot B, right? Because it's got a negative slope, and the dots are, you can definitely tell they're making a line. So 0 would be no correlation, and I really think scatter plot C has no correlation. Look at that, it's just like a cloud of dots. Nothing headed up, nothing headed down, no trend, no pattern to that data. And then that would leave 0.9 to be scatter plot A with a positive, strong positive linear correlation. So you're looking at this scale basically for correlation, and how strong or how weak is it? Well, based off of that number, how close are you to 1 or 0 or even a half, you know, that kind of thing. And getting a feel for the dots and being able to read them. Here's problem number 50. All right, we're solving for C. Oh, we got some literal equations here. So how am I going to get rid of that 1/2? I'm going to write this down. How do I get rid of a half? We've been talking about this for a while now. You get rid of a half by multiplying by the reciprocal. So the reciprocal of 1/2 is 2. So I'm going to multiply both sides by 2, or 2/1, but 2. 2 times a half is 1. So we're looking at 2a equals b plus c times h. I probably wouldn't distribute the h. I mean, I guess you could. I would go ahead and divide by h. 2a over h equals b plus c, and we're solving for c, so we're going to subtract b on both sides, and we get 2a over h minus b equals c. So which one matches? Not A, not B. Ooh, look, C. I like C. C is the one that I'm going for. Here's problem number 51. All right, so this has a table, it has a scatter plot, and they want to know which equation best models the farmer's data. I don't think that this one would be on the non-calculator portion, but it is one that you could figure out without a graphing calculator. So I'm going to talk you through how to do it without a graphing calculator, and then go ahead and pull the graphing calculator in to make sure that it agrees with us. So I can tell that this is a quadratic. It starts going up and then it curves down. So it's not going to be best modeled by a linear function. So it's not going to be m. It's not going to be best modeled by an exponential function, so it's not going to be p. So it either has to be r or s. Both of these have a negative in front indicating the parabola is opening downward, so I agree with that. These pieces are the same as well. So here, this is the y-intercept. So would this parabola have a y-intercept at negative 43 or positive 43? Well, positive 43 is like up here. It's not going to cross the y-axis there. So R is going to be the best answer. It's going to have a y-intercept at negative 43. Now let's say that for some reason you couldn't think that way through or anything like that. That's okay. I'm all right with that as long as you know how to work with the graphing calculator. So pulling up our graphing calculator, we're going to go stat and enter, and this is two variable statistics, so I have to fill in L1 and L2. All right, there I have my data in the calculator, and then I'm going to do a quadratic regression because, again, it appears to be a quadratic model. So I'm going to hit stat, I'm going to hit right, and I'm going to choose 5, the quadratic regression, and hit enter a whole bunch of times. And there it is. And if we compare, they did do some rounding, right? Because that's that 8 has been rounded up, that's been rounded, but looky there, negative 43. So R is going to be your best answer. All right, here's problem number 52. All right, which of the following relations is a function implies that there are 3 that are not? So remember, in order to be a function, you cannot have repeating x's. So A is out. I see a repeating x. Hey, B looks good. Let's check the others. Ooh, we've got -1 and -1 and a repeating x, so C is out. D is also out. There's 2 -3s, so B is a function. All right, here's problem number 53. All right, so this is about profit generated by selling shirts. So X is the number of shirts. So if I look at F of 200, remember it's usually F of X. That means that X is 200. So they're telling us 200 shirts. That's what we're dealing with. The question is, what are the what's the profit, right? Because that's the Y value. It's a profit function. So it's definitely got to be about money. So it's not going to be A and it's not going to be C, because that says that they're telling us that how many shirts were sold, and we already know that there are 200 shirts. Pretty sure it's not $15 made in profit if we sell 200. We'll double check that. I'm pretty sure D is the right answer, but let's stick it in the calculator just to be on the safe side. we're plugging in 200. So 15 times 200 minus 25 is 2,975. So D is the correct answer. All right, last one, problem number 54. What's the domain and range of the function? So how far left does it go? Looks like -8, and there's a point there, so it gets a bracket. How far right does it go? Looks like it goes to 6. That also gets a bracket. How low does it go? It goes down to -4. That gets a bracket. How high does it go? It goes up to 8. All right, so there's your domain and your range. All right, that's it for today's EOC review. I'll see you guys in the next video. Bye.